Let's begin today by going over the answers to the graphing problems that you were to solve in Lesson 9. So let's turn to packet page 36. Remember, if I'm going too fast, you are welcome to pause the video to take notes and then resume as you need to. So this page right here, it asks which of the graphs showed that one of the runners started 10 yards further ahead of the other, and explain your answer. So what we have to do is we've got to look first and see what it is that our graph is showing us. On the x-axis, it's showing us time in seconds, and the y-axis is showing us distance in yards. So when we look, we see that this runner started at the 0-yard mark, and this one started at the 10-yard mark. So graph A, excuse me, is the one that shows that one runner started 10 yards ahead of the other. But let's look to see what the other graphs showed us. Graph B shows that they both started at the 10-yard line. Graph C shows that one runner started 20 yards in front of the other runner. And graph D shows us that they both started at the 0-yard line. Let's go to packet page 37. In which of the following graphs below are both runners moving at the same speed, and explain your answer? Remember to calculate speed. It is speed equals distance divided by time. So for the purpose of me typing this stuff on the screen, I just tried to make it as simple as possible. And this fraction bar right here, this dividing line, that's going to be my divide symbol. So I did 10 divided by 4 is 2.5 yards per second. And then this one was 5 yards per second. That one is not the same speed. This one I had 20 yards divided by 4 on this top line, because see, it went from 10 to 30. So 30 subtract 10 is 20 yards. That's where I got that from. I didn't explain that on this one because it was at 30 yards and 20 yards. So the difference of 30 and 20 is 10. And on this, it is 30 and 10. So 30 subtract 10 is 20 yards. And it took 4 seconds for them to complete it. So that's how I got these answers. Over here I have 10 yards because it went from 20, subtract 10, see the difference here, divided by 4 seconds, see the 4 seconds, equals 2 5/10 or 2.5 yards per second. Then on this one, I see they started at 20, they ended at 30, so 30 subtract 20 is 10, and I see that it took 4 seconds, so it's 2.5 yards per second. Same thing on this one. We started at 10, they ended at 20, so 20 subtract 10 is 10, still yet 4 seconds, so 10 divided by 4 equals 2.5. This one is the same speed. On this one, the lines cross, so you have to pay close attention to what it is that you're doing. And notice I put it at the end points because I didn't want you to get confused. So on this one, I'll start with this one. I have 0, and it went up to 30 yards. So 30 subtract 0, still yet 30, divided by those 4 seconds equals 7.5 yards, or 7 5/10 yards. This one started at 10 yards, ended at 20 yards, so 20 subtract 10 is 10, divided by 4 gives me 2.5 yards, so this was not the same speed. Okay, let's go to our next page, which was page 38. and we have the 4 graphs that they're wanting us to match the description to the graph. I have graph A matches description 2 because the line is moving up at a constant rate. See the distance here? We have distance over time on this line right here, and it's just moving up at a steady pace. On graph B, we have the distance on Y, we have time on X, and we can see that as the time is continuing to move up or increase, the distance is getting less, so it is coming back. So the distance is decreasing. That is number 4. On C, the car is stopped. We see the distance, they went so far out and they quit, and the distance is not changing, but the time is continuing on. So the car is stopped. And then we have on D, we have that they increased at a pretty steady rate, and then the distance stopped increasing as rapidly, but time continued to go. So this would match 3, and this is because at the top of the line it curves so that the time is passing, but the distance does not go up as much. And I made a typo there. There, we got it. Let's go to packet page 41. We have that graph E matches 7, and it was because that the speed increases from 0. Now, this is one I want to show you it because it does change. I hope that you notice that this is now speed and not distance. And this is still yet time. I'm sorry, that one's blurry. So this is showing that the speed is increasing as time continues. Not the distance, but the speed. So graph F shows that it matches 8 and that the car is slowing down. The speed is decreasing as the time continues. Graph G shows that it matches 6 and the car is traveling at a constant speed. I was afraid that on this one that you would put 5 because of where we were dealing with distance before. This is not showing distance is staying the same, but showing that the speed is staying the same as time continues. So if the speed is staying the same and it's at this up here, it's showing that it's not stopped, but that it is continuing to move on. Whereas on this one, the speed is at 0 and time is continuing. So it is showing that it is stopped. So G matched 6 and H matched 5. Now on to packet page 42. I moved the graph right over here so that we could see it while we talked about the questions. It shows the 3 runners and they ran a 100-meter race. We see that this is showing the meters and this is showing the seconds. It says which runner won the race. We see that all 3 finished the race, but which one won the race? We see that with this time, the one that made it in the least amount of time was Albert. So which runner stopped for a rest? We see that on this line we come up right here and we get to the 8-second mark, and then the distance doesn't increase for a few seconds, and then it starts to increase again. So Charlie was the one that stopped, and he stopped for 3 seconds because the distance did not increase, but time continued. And how long did it take for Bob to complete the race? we see that here is Bob. He finished the race, and we look down and it's 14 seconds. And it said calculate Albert's average speed. So we take the 100 meters. Calculate Albert's average speed. I think I said Bob, I'm sorry. Calculate Albert's average speed. So right here, it was the 100 meters, and he finished it in 12 seconds. So we take 100 divided by 12, and that equals 8.3 or 8 3/10. Or you may have had 8 and 33 over 100, depending on how you answered it, whether it was a fraction or a decimal. Potatoes, it's still the same. So let's look. I'm sorry I didn't put the page number on this one. I believe that this is page 43. Yes, your packet page 43. Let me type that right here. Packet page 43. Okay, so we have segment OA is accelerating, AB is at a constant speed, BC is decelerating, CD is at rest, DE is accelerating, and EF will be at a constant speed right here, because the speed is continuing. I know that's not on there. That's okay. It's at a constant speed as time passes. So now let's turn to page 44. And let's look at our answers here. It says number 1, what does each point plotted on the graph in figure 1 represent? The different positions of the objects from the starting point. Number 2, what does line A tell you about the speed at which object A moved? And one thing we have to notice here is object A is this broken line, and object B is this top line. That was one thing that kind of confused me just a little bit at first, since it had been a year since I had went over this. And so I thought I would mention that just in case that you made the same mistake. And it says that object A, it moved at a steady rate. We can see that there wasn't any big changes from the point that it started out. Then object B, on number 3, it did not move at a steady rate. We see that it was zigzaggy there for a little bit. Then on number 4, it says, what can you tell about the way object B moved from looking at the curve? That's just talking about how the line looks, and that it was moving faster than object A. And it says, which object moved faster for 50 meters, and how do you know? For the 50 meters, we see that object B moved faster because it took less time for object B to reach 50 meters. We see that right here. It took about 8 seconds, whereas for object A to reach 50 meters, it took about 18 seconds. Then we have on the next page that number 6 was about 3 miles per hour. Number 7, you can see the 3 different miles per hour here. Number 8 is 6 miles per hour. I just did distance divided by time. Same thing on this one, and I just kind of made the chart. I just started with this as being the first point, and these were increasing, so I just added these up and continued across. It didn't really make it clear on this, so I just did it this way. I'm not really